Next comes the insertion. We have created the list to insert some items, whatever comes, because data structure, a linked list is a dynamic data structure, so we keep on repeating or changing the size of linked list. So this is how logically insertion to the linked list look like. So we have a start pointer here. This is the before insertion, and this is the example linked list. This is the first node. This is the header node which stores the address of this. Let's say this is 1000. So start is going to store the 1000, and similarly we have some other variables, another nodes. So this is the example linked list. So this is the last node with null or zero value or 0 point. Now we want to insert. Let's say we want to insert some node here. So what we will do is, this is the dynamic data structure. We have pointers, we have addresses. We just need to update the address. This node A has the next address of node B. But if we change this pointer so that it can point to some another location, if we have updated only this pointer, then this list will be lost. Otherwise, what we will do is, we will update or change the next address of node A to the newly added value node, and again this is the node, this is going to be having its own pointer value. So we will store the address of next node into this pointer. So we will fetch this address first, we will store into some temporary variable, and we will copy that same address to the new node which has been added. And now this got empty. Now we will store the address of this node which has been inserted into it. So this is how insertion works. So this is the logical way how you will insert some item into the linked list. Logically it's easy to understand because we are just changing the addresses. This is a dynamic structure. We need not to worry about the sequence or the order of the list, because we can add anywhere onto the list. Just we need to keep in mind that we need to change or update the address carefully so that we don't lose the entire list or the nodes which has been inserted or are placed at the end of the list. So this is how insertion looks like. We will change or update the pointer values or the next pointer values of them. So this is insertion with the one additional point, because here we just looked at we have a node somewhere which has been created at some another location, because in the definition of linked list we looked at physical placement or the storing of node does not affect the linked list. That's how linked list is dynamic in nature. So we can save the data item anywhere, and after that we will change the pointers, so that will become a part of current linked list. When we created a linked list, we were having some additional list which is storing this free space. So avail list is the nodes which have an empty space. So while insertion, what we will do is, we will firstly check if some space is available in the avail list, some node is available. Then we will do is, we will change or we will pick the address of this and we will assign this to this value, and then we will insert and update the pointer of this value which will point to the address of node B. So with the help of avail list, we can insert the item just like we did in the previous slide. The only difference is we are picking the values or the storage memory which are in available list and which are part of the actual or parent linked list. Now we will look at the algorithm. This is the simplest algorithm when we are inserting the element at first or at the starting point of the linked list. So we are going to add or insert the item, and here we are using the available or avail list also. So firstly what we will do is, we will check for the overflow condition, which means if linked list is already filled and there is no space available in the avail list, so that is going to be the overflow condition. So we will check for the overflow condition in the first step. So if available is null, which means it reached at the end of the list, so no space is available, so we will print the error message of overflow and we will exit the execution. We will not execute these points. Otherwise, if available have some space which can store the next node, so we will move further and we will execute these statements. So first thing is, we will remove the first node from the available list, because we want to store the item which has been received to us, which we will need to insert to the already available linked list. So what we will do is, we will remove, we have created one variable onto which we have stored the address of first node of available. So inside avail, you can see this avail stores the address of first node of available list. So we have created new variable here. We have stored the address of first node of available list to this new variable. This is pointer. This is having a address of first node in available list, and we have updated the available list because if we have removed this item from the available list, now available should point to the next item. So that's why we have taken the link pointer, because this node's address is stored in this node n. Now we can pick the address of this and we can assign that value to the available, and it will now point to the next node in available list. So what we have done is, in avail, what we have is address of first node, and inside first node, the second part of first node stores the address of second node. So we want now this avail should point to the next node. What we can do is, we need two steps to do is, we have taken another variable, and to that we have stored the current value, current address, which is the address of first node. We have stored it into this location, and now we can safely update the value of avail. So whatever is in the link value or the address or pointer value of the available list, we have stored that address onto the avail. Because this address we require, we need to follow the step-by-step procedure. We have saved the current value or the address onto some another variable. Now we can easily update the available list. Now available pointer now points to the next node into the avail list. Whatever item comes which need to be inserted, we will pick the location. Now new is having the address of first node of avail list. So info is our actual list. So at the index, this address at the first node of avail list, we have inserted the item. Next is, now this has been copied to the new location. Now address also need to be changed because this is going to the first node of this list. Now we have stored the item here into the avail. Now avail is pointing to new item. Now we want to change the pointers. How we can do is, we will pick the link new and we will store the start value here. Start stores the address of first node. Now we want to insert the node n at the first location. So what we will do is, we will pick the address of start value and we will put it into the next pointer of newly created node. So in start we have location of first node of actual linked list. We want to insert the new item, new node from avail list onto this. We have inserted and we have updated the avail list. Now we want to change the pointers. In start we have a location of first node of the linked list. We will pick that up and we will store that value to the newly created node. Now this node will point to this node, and this address need to be changed again because now this pointer will be changed. So this is what we did in this step. We have picked up the start value and we have copied that address to the newly created data item or the pointer size of the new node. New node now points to the original first node and onto the start. Now start should point to the first node location only. So whatever is the memory location of this, start should point to this node only because this is going to be the first node, new first node of this link. We will take the new address because new pointers have a address of that node, and we will copy that to the start variable. So this is how we will change start value for the header node of the link. So this is how you start or insert the node at starting point of the linked list.
If you found some value in the content shared in the video, please hit the like button below. Also do subscribe to the channel and don't forget to click the bell icon so that you don't miss any updates. Thank you for watching.